In part 4.2, we'll be trying out the bindings for SignalR we created yesterday. Let's not waste time with the introductions and start right away. We've set up the project, and what we want to do next is create a SignalR hub that we will try sending various F# types and seeing how they arrive at the other end. Before that, in order to create a hub on the .NET side, we need to find a SignalR package to import. We recall from a previous video that it has a bunch of them, so we'll first do some research on their differences. By the looks of it, we'll probably need to either install the Protocol.Json or the MessagePack package in order for it to work. That having said, we'll start out with the common one just to see if it fails. Sorry viewers, actually it seems we got it wrong. Though there are SignalR packages on NuGet, as you can see here, the library is in fact bundled with ASP.NET Core. So we don't have to install anything, we'll use the bundled one. It seems SignalR does support scale-outs using readies, but there is little chance of us being able to serialize closures, so we'll ignore that possibility for now. What we will do here is add a hub to the project from scratch. The way ASP.NET Core app setup works should be familiar to you by now. If not, check out our previous videos. We got the WebSocket connection working. We'll want to clean up the bindings a bit. That object option should pretty much always be object. Here is how the TypeScript type of the hub connection on looks like. It seems the bindings generator translates the AnyType to object option. We'll do a quick search and replace to turn those into regular objects. Also, the onHandler should be the one to handle the invokes from the server, so rather than unit, we should be returning obj in its callback. Good. We have a lot going for us now. We can send messages to the server and send them back from the server as well. One thing we are confused about is why the string we send back from the server arrives split into a couple of different arguments. Let's try using the sendCore method instead. We'll wait a bit for it to rebuild, and if we look at the console, nothing is showing up. In fact, we aren't even getting the server receives to show up in the terminal. It turns out that the reason for this is a Fable compiler bug. Hopefully it will get fixed soon. For the time being, we'll work around it. Next, let's figure out why that string comes in split arguments. We could check it out in the debugger, but instead, since we reasoned it out, let us point out what the problem is directly. Check out the original type in the TypeScript file. It is not an object array, but instead it has those 3 periods next to it. That is a parameter argument array. In F#, we can also use those by putting in an attribute, but the problem is that the attribute can only come on the argument, not its type. So the binding that we have is incorrect. In fact, we cannot even express it in F#. Instead of indexing into the first element of an object array, what we are doing instead is indexing into the first element of the string. Next, let us try passing multiple arguments back to the client. The way Fable compiles functions is that tupled arguments are passed in arrays and get destructured inside the function body, while the curried arguments end up being treated like regular JS arguments. So we'll try doing the same thing here, to see if we can use that to receive multiple arguments from the server. And it doesn't seem so. The function gets compiled in a nested manner rather than a single function with curried arguments. And to make things worse, it doesn't seem like the tuples being sent from the server to the client are being serialized correctly. We'll open it in the debugger just to see what we are getting. Correction, the tuples are getting serialized just fine. It is deserialization that is the problem. To be more precise, since the JS side is untyped, the client library simply has no idea how to convert the tuples into the correct form. All it is getting is a JavaScript object with the 2 fields, while the code itself is expecting an array. So we'll pause here to do some research on what we should use to serialize and deserialize various types. We're back. We'll go with Thoth.Json. We looked at how Fable remoting, Elmish Bridge, and the Fable SignalR library do it, but there isn't a straightforward way for us to reuse the way they do serialization. The Thoth.Json library is the only straightforward way to serialize objects to JSON strings and back. No other library has both Fable and .NET versions that work side by side. We do find this very disappointing. We had wanted to find a library that could be used to do serialization in a more performant manner, but the Fable ecosystem is sparse and only supported by a small number of stalwart contributors. It is a pity that we couldn't find an efficient way to do binary serialization, but we'll do something on our own about that as an exercise. We'll do the MessagePack bindings here. By now we are familiar with the act of doing it, so enjoy the time-lapse music. We ran into a really weird writer ID bug whose investigation took up an hour of our time, so to get around it, we just put the stuff in the other module into the first one. We are really annoyed at this right now. Cache invalidation didn't work to fix the ID using stale data. Let's get back on track. As we were saying earlier, we are very sad the serialization options are limited to JSON with Fable. If we wanted to make use of a binary format, we'd have to make our own. We've done this before in different contexts, and it is at least half a week of work. It is not something that couldn't be dealt with, but it is really annoying to have to do that if you are in a pinch and want to something you could use quickly. So what we'll do is compromise a little and show you how you can compile the F# types to intermediates that could be more easily transferred to Fable. We'll start things off by showing how records and tuples can be serialized to arrays. Since we'll be serializing all the F# types to primitives and arrays of them, the JSON and MessagePack protocols that SignalR is using won't get confused as to how they should be transferred over to the receiving side. Not bad. We've taken care of all of F#'s functional types, plus the array. We'll try these functions out with both the JSON and the MessagePack protocols. The point of this project is to get familiar with both serialization and serverless computing, so we might as well take the time to do it. In one of our previous videos, we were confused as to why cross-module inlining wasn't working for us. But since those Thoth auto functions wouldn't work without it, there has to be a trick to it. We've peeked at its source and figured it out. Instead of let statements, what we need are static member inline methods on an interface type. Let's give this a try. Lame. The JSON protocol is more useless than we thought it would be. We thought that we might get back .NET objects at the other end, but no such luck. Let's try the MessagePack protocol. The Donkey Kong soundtrack ran out, so I'll provide extra commentary. As far as serializing and deserializing JSON is concerned, we'd have to write a parser, so our suggestion is that you just use Thoth instead. In the screencast right now, we are pausing to make the restarts go faster, which is not something we usually do, but we'll be doing it more regularly from here on out. Anyway, MessagePack is quite promising. It actually gives us back the .NET types. It's just too bad they are the wrong ones. That tag should have been an int, but we got back a byte. Since we don't need union cases with a large number of tags, we might as well convert those tags to bytes internally, which are 8-bit values. 256 is more than enough cases for any possible union type. But for the rest of the numerical types, we'll need to make sure they are of the right size. And since this just happened, damn, we thought this protocol would at least be good for transferring large homogeneous arrays, but since it converted what we thought would be an int to a byte, it might do that for arbitrary elements. During deserialization then, on the .NET side at least, we'll have to make sure the primitives are all converted to the expected type. And it turns out .NET has a library function just for such a purpose. It's called convert_change_type. Anyway, at this point, we have no idea why we are even doing this. Because of all the reflection and runtime type passing, the performance of this is going to be horrible. We only barely managed to create something that could be useful, but personally, we'll be using Thoth. If performance was an issue, we'd be writing our own binary serializers and passing byte arrays. If you wanted to do something like that, now you have a starting point for that. We wish we could use compile-time metaprogramming for this. We know that C# has source generators, and that would be a good fit for what we want to do, but we don't think we could use those on the Fable side, so it is somewhat pointless. The point being writing a great piece of code. We can't really do serialization to perfection in F#. We could do it in our own language spiral, but that will be a subject for another day. Performance aside, understanding a little bit of .NET reflection should be useful for all kinds of data serialization tasks that you could encounter in the future. Because you've learned that from us, you should like and subscribe. And we'll be back shortly.